Welcome to our channel. In this session, we will discuss beam search algorithm. What is mean by beam search? It is a heuristic search algorithm. First, you know the difference between a normal algorithm and heuristic. Normal algorithm is blindly it expands the node. But coming to a heuristic search algorithm, it follows some heuristic function to get the maximum profitable node. Now, this beam search is also a heuristic search algorithm. Now, how the beam search algorithm works? It is looks like best first search. You know the meaning of best first search, but it is like best first search, but instead of expanding all the nodes at each level, it maintains only the limited number of nodes. For example, this is at level 1. Assume level 2 has 4 nodes. Instead of expanding all the 4 nodes, I assume my beam width is equal to 2. Then at each and every level it expands only the best 2 nodes. Now you got the point? Now compare it to remaining, it is faster. Why it is faster? No need to expand all the nodes. I am expanding only a limited number of nodes. And at the same time it uses a less memory. Yes, this is the main thing related to beam search. Now, what is the main idea? Just now we discussed the main idea is instead of expanding all the nodes, we are expanding only the best k nodes at each depth. Now, here k means the beam width. You need to choose the value of k. Suppose I assume k is equal to 3. Then at each level I am expanding only 3 nodes. K is equal to 4. You are expanding only 4 nodes. Okay. Now, like BFS, like breadth first search, a tree is constructed by generating the success at each level. But you already know how many, what is the K value? Only expand that many number of nodes at each level. And which nodes are expanded? For example, this node, assume I have 5 successor. My K value is equal to 3. Now the question is, which 3 nodes are considered? That is, which 3 nodes are expanded? That is based on the heuristic value. Now you got the point. Anyway, you are fixing the K value, but which number of K is considered based on the heuristic value. Based on the heuristic value. Now here the selection is mainly depends on this one. What are the main characteristics? The main characteristics is the first one as usual, width of the beam. Width of the beam is how many number of nodes are considered at each level. That is, at each level you are considering 3 nodes, or considering 4 nodes, or considering 5 nodes. The number of nodes you are consider mainly influence the algorithm. Yes or no? For example, my k value is equal to 5. That means I am considering all the nodes. Then what is the use of beam search? Suppose my k value is equal to 1. Smaller k value means may last the important nodes. So the K value, the selection of beam width plays a very crucial role. And one more characteristics is branching factor. Branching factor in the sense at each level we have some set of nodes, and how many nodes are considered again for expansion. Again for expansion, branching. This is also plays very crucial role. And one more characteristic is memory. So memory means based on the number of nodes only the memory requirements. Suppose you have considered less number of nodes means the less memory is required, automatically performs efficiently. These are the main characteristics of a beam search algorithm. Now, what are the steps you need to follow? Anyway, the procedure, you understand the basic procedure. What is that procedure? Identify, that is start from the root node. From this generate all the successors. Assume this is the current node. For this current node, these are all the successors. Now apply the heuristic function to each successor. Apply the heuristic function to each successor. And then among all the successor, select the k best successor. K means my beam width. Among all the successor, select my k successor. Now, for example, my k is equal to 2. Assume this is one node, this is one node. That is the best two nodes. Now, what happened? Expand only these k successors. Expand only these k successors. This process is repeated until your goal node is available. Your goal node is available, or no nodes are left. That is, goal is not at all available. My entire tree is completed. You got the point? These are the step-by-step procedure of beam search. Now, what are the advantages and disadvantages? Very simple. Advantages means efficiency. Why it is efficiency? Instead of expanding all the nodes, I am expanding only the limited number of nodes. So obviously, the memory usage is reduced. Flexibility. Depending upon the problem, we can change the size of the beam width, and you can change the heuristic function, that is flexible. Scalability means it is suitable where the solution path is vast. That means if you have a vast number of paths, or if you have a complex path, for that also it is very easy to calculate. Why? No need to calculate all the nodes. If the path is very large, instead of calculating all the nodes, we are calculating only limited number of nodes. These are the main advantages. Coming to disadvantages, suboptimality. What is mean by optimality? Always you need to find the best solution. For example, if I am selecting, assume these are the 5 successors. Maybe in this situation, I am selecting these 2 best nodes. But there is a chance for generating the best solution by expanding this node. That means the beam search, there is no guarantee of the algorithm it will generate. Why? The selection of node depends on the beam width, and the selection of nodes depends on the heuristic function. Suppose if the beam width is very high, then automatically it behaves as a normal BFS. If the poor heuristic function, suboptimal solutions may leads to wrong answers. You got it? Now, this is one example. Now I will explain this example, how the beam sets, and we will close the topic. Assume this is my original tree. Whatever place in the brackets specifies the heuristic values. According to my question, lower is the better. Assume beam width is equal to 2. Now, first at level 0, I am starting at node A. Now, node A is expanded into B, C, D, right? Node A is expanded into B, C, D. The heuristic values are 6, 4, and 5. What is the next step? Among this, my beam width is equal to 2. Select the 2 best nodes. What are the 2? For C, the value is equal to 4. D value is equal to 5. Here I assumed lower is the better. Now, what are the nodes I selected? I selected C comma D. I selected C comma D. That means my tree is A to C and D. You got it? I am ignoring B. Why? It has the latest heuristic value. Now, in the next step, expand C. For C, the value is G. So, if you are expanding C, what you are getting? G with a heuristic value 1. If you are expanding D, you are getting this one. So, here G is there, here H is there, here I is there. Now, 3 nodes. What is the K value? K value is 2. Which 2 nodes are considered? This has a value 1, this has value 2. Now, you are keeping the 2 G comma H. We are keeping the 2 G comma H. Assume my tree is completed. If the G is the goal node, we stop the process. Here, some more tree is there. The same process is repeated. The same process is repeated step by step. Now, what is the answer? A to C, G, H. So these are here. Observe B, E, F are ignored because these are, if you are not expanding B, these two are not at all required. These two are not at all required. This is my beam search algorithm. You got it? This is the example. Now the final question is, in what situations we are using this beam search algorithm? The main situation is if the search space is very large. Instead of expanding all the nodes, we are expanding limited number of nodes. If you want to get approximate solutions, we are moving to beam search. If the speed and memory is important, we are moving to beam search. These are the situations where we are using beam search. But remember, here beam search is incomplete. Why it is incomplete? It may miss the solution. That depends on the k value. If the beam width is small, maybe the algorithm is fast but less accurate. If beam width is larger, the algorithm is slower but more accurate. Depends on beam. This is the beam search algorithm. That is the end. Thank you.